Joseph, congrats on the first. Hope your day's going good. It feels just a touch loud. I think that's a little better. It's good to hear. Yeah, it's pretty good for me too. All three of my classes are assigning homework now, and so it kind of feels like a lot right now, at least. But I'm hoping to make some progress today. I definitely could not finish all my homework today, but I can get something done, I'm sure. Hey, BR Gaming. I remember you asking me that every time you come in chat. Yes. Just still getting things set up here. Okay. Yeah, I just streamed like 3 days ago. So I guess I'm starting out with complex analysis homework, and I was trying to do this yesterday and I couldn't figure it out, but the task is to prove this identity for complex numbers. And I'm doing it the caveman way of just breaking them into real and imaginary parts and hoping that I can see something. So far, I really haven't, though. Hey, Stooky, yeah. We did it, yep. This is the complex analysis homework too. It's pretty tame right now. It's just like nothing that's particularly like crazy yet, but this thing I'm trying to work through at least like first today. But yeah, so I need to go back. They asked to draw pictures for some of the previous questions, and I didn't do those. And so this is just scratch work. My actual homework is going to be written in LaTeX, but I want to figure out the solution before I bother writing LaTeX. Did I study binomial? I know like the binomial theorem, if that's what you mean. So if I want to prove this, I mean, should I actually calculate the magnitude of those two complex numbers? As long as I'm going to do caveman math. Well, that's just a real number right here, isn't it? Got a clean room? All right, good luck. Godspeed. I got to do cleaning too, but I'm prioritizing homework first, which may or may not be a good choice. All right, well, yeah, this is just a real number, so the magnitude isn't very interesting. What's the magnitude of this thing here, though? Uh, hey, K-Pars. It's looking over like heaps of less than 2 times. I guess so. This one is going to be hard to draw because I have to draw a picture that represents this inequality, and I don't really know the geometric meaning of this right now. Then hopefully we get some cancellation. Oh wait, I don't think we do get maybe we get a cancellation. ABCD plus B squared D squared. Today's your birthday, tomorrow's your math exam. Well, happy birthday, and I'm sorry that you are having a math exam tomorrow. Yeah, these are complex numbers. Yeah, it's just that there's like 4 different things to draw here. Well, even more than 4 when we do the combinations of them. So I guess I'll cross that bridge when I come to it. Okay, so we are getting the ABCDs to cancel. That's something. Mayas, thank you for the follow. Okay, so theoretically this thing is bigger than this thing. Oh, well, okay, now it seems more clear. This step feels a bit stupid, but it'll make the inequality a bit clearer to see. Okay, yeah, I'm sure there's a more elegant way of doing this, but the caveman way... Ooh, no. Yes? No. Maybe so. Can you repeat that question? I forgot we're gonna get the ABCD term in this when it canceled from the other one. So if we can justify that 2ABCD is less than or equal to they have a squared c squared in common. They have b squared d squared. Okay, so a squared d squared plus b squared c squared. That's what I need to justify now. All right. Good luck with your studying BR gaming. That looks like it factors, but well, I mean, I'm not allowed to work on both sides of this inequality, so I'm trying to prove this inequality. Hey, Atharv. I would love to find some way to not do this caveman stuff. I was thinking about like the magnitude of the conjugate is equal to the magnitude of the not conjugate, and that maybe we can pull some trick with that, but I couldn't really find much. I was also wondering about like multiplying through by like W or Z or something and seeing this, like it wouldn't be a cancellation with the conjugates, but maybe getting a different form that's easier to work with. I don't know. Maybe the fact the conjugate would point in the minus direction matters. Yeah, I mean, we could go for the drawing first and see if that helps us with the algebra. Wait, I don't want to do that. I want graph paper. Flash. Oh, wait, there's dark mode graph paper. Ooh. It's fancy. Hey, Sage. Um. So let me copy this. And this is potentially a drawing that I'll turn in for my homework. So I want to do a good job of drawing this and make some straight lines. A relatively good job. So let's put z in green. It doesn't matter the exact value of z, but we'll just put z right there. Why not? So z conjugate will be right there. Then for a variety, we'll put w up there. So w conjugate will be right there. Then I guess we'll do the sum. Well, we need to figure out the products first, don't we? What's the geometric interpretation of complex multiplication again? The angles add, I remember that. And I guess the magnitudes multiply. Should I just get exact values here? I think it's going to be worth it for this. Oh, yeah, K-bars. Okay, let me make my numbers a little smaller, and let's actually calculate things. I think. Oh no, that erases the lines? Bruh. Layers would be nice. Now that I know that that's true. Okay, so let's make z like 1, 2 then. We'll make w minus 1, 1. Just for fun. Okay, so z is 2 plus I. W is minus 1 plus I. And I'm going to actually like calculate these. So we want w z conjugate. So that's minus 2 trying to mental math this. Negative I times negative 1 It's positive I. Why am I doing... No. I am doing this in an order that's going to confuse me. Do this 2 times these 2, and then do this minus I times these 2. Minus I squared is plus 1? Okay. W conjugate Z. So this 2, negative 2, minus 2I. Oh, you know what? These should be conjugates of each other, right? Let's verify it, but it should be negative 1 minus 3I. Minus 2, minus 2I, minus I, plus 1? It's a crappy 1. Minus 1, minus 3I. Look at that. Okay. Hey, Abby. Man, there's like a million things that I'm going to have to draw if I want to do each of these components. Maybe I'll do just their sum. Combinatorics, I'm really bad at. I know the basics of it, but I have a pretty hard time with those problems. So actually this is... Okay, you know what? This has helped because I've just realized that I could rewrite this as WZ conjugate conjugate, which means it's just equal to Dora. Hello. Thanks for lurking. Which means it's just equal to the real part of WZ conjugate twice. And the real function has properties, right? Like for the product. Yeah, this might be the key to proving this. So first off, the real part of Z conjugate is equal to the real part of Z. The real part of 2 complex numbers multiplied. That's the thing that is going to make or break this. Like what combinatorics is about, Abby? Combinatorics does cover a few things that, like, like a variety of things that seem different. And to some extent, they are different. So I'm not the best with combinatorics. I'm not the best person to like really describe what all it covers. But like some of the basic problems are like how do you count things? And I don't just mean going like 1, 2, 3, 4, 5. I mean like, you know, how many ways are there to like arrange things or permutations of things. But there's also part of combinatorics that's called graph theory, which is how are things connected, and how can you like find paths through these things. There's also like coloring problems with the 4-color theorem, I want to say. That's like a famous combinatorics result. So it and I think there's at least one component of it that I'm forgetting. But when people are normally introduced to combinatorics, it's they usually just focus on the counting aspect of it. with permutations and combinations, but it is more than just that. How many ways can you get 10 out of 25 questions right in your 4 multiple choice test? Oh, yeah. Hey, JC. Interesting, I never thought it was related to graph theory. We use directed acyclical graphs for casual causal modeling, not modeling, not casual modeling. To my understanding, graph theory is inside of combinatorics. I think it definitely has applications way outside of combinatorics, but I think its home is in combinatorics. No worries, Abby. Thank you for the question. You've seen users mentioning it along combinatorics graph theory. Yeah, that makes sense. Can I do something better with this? Does this mean something? Oops. We can get rid of the real part. It looks like a determinant, which is kind of funny. But it's not quite. Yeah. Yeah, exactly, K-Pars. I think it wouldn't... How would the determinant have to look? It would have to be like A, B, C, D. We could interchange the D and the B. It's not quite how we would... It wouldn't quite match up with how, like... It's not like the rows are the complex numbers, or at least not exactly. So I think it's just more of a coincidence in happening to use the same letters. Hmm. You know what? I'm kind of realizing that this AC minus BD, I already reached this. No, I didn't. Uh, sorry, now I kind of want to go back to trying to do the actual proof now that I realized that. uh, I was debating if I should let myself be distracted or not. WZ conjugate plus W conjugate Z is equal to WZ conjugate plus WZ conjugate conjugate, which is equal to twice times the real part of WZ conjugate. Oh wait. Oh, did it? I think we may have done the proof because part B. This is probably the way that we were intended. So this is part C of a three-part problem. And the part just before this had us establish this bad boy right here. Yeah, we're trying to prove this inequality for complex numbers. I may have just cracked the case though. Yeah, this is it. Okay. Whew, okay. No more caveman math. Get rid of all that. Get rid of all that. Oh wait, we have a little bit of we need to establish that the conjugate part holds. I didn't mean to hit that button. Okay. Forget the picture for now. Picture pretty. That's so weird how it skips around like that. Okay. So we know by the result in part B, this is less than or equal to twice the real part of W times Z conjugate. So we do have one more step, which is to show that the magnitude of WZ conjugate is equal to the magnitude of WZ. That should be true, right? I don't see why not. And for that, we might caveman math. Ooga booga. Same distance from the origin. That's a nice way of saying it. So WZ conjugate using this right here. AC. Ugh, mental math. I'm gonna mess it up if I do this with mental math. AC plus BD plus I. Wait, these aren't going to be equal, are they? This is going to be a plus, and that's going to be a minus over there. If we can... Oh, is that a fact? Oh, wait, yeah, it is, duh, because if we use the exponential... Okay, yeah. Yeah. That's easy. That's a lot easier to see with a... So actually, if... Ugh. I'm gonna give them complex definitions too, just so I can justify this part. Um, you know, I should no, I should do this separately. I should do it like JC is saying. Um, there you go. And so that will be the proof there, as long as we can throw in the justification for these steps here. Rudraksh, you that's a problem from classical mechanics. You can try me. My mechanics isn't the strongest, but I can take a look at it and at least tell you whether I can help you or not. Oh wait, So the thing I wanted to show, I was about to split. No, I can't do the. I was about to just get rid of these exponentials because their magnitude is 1. But I'm implicitly using the identity that that I'm trying to prove here. So I shouldn't be doing this. We might need to do caveman math. I am a fan of caveman math. Integration part only? Yeah, if you want, you can tell me what the question is and I can take a look. Stefan, I got a 10 for this semester in algorithm and data structures. Are you proud of me? Well, it's 10 out of what? Is it 10 out of 10 or 10 out of 100? Okay, 10 out of 10. I am proud of you then. Nice. Very well done. So I should be like, out of 1,000, you know, I would still be proud. If it's not a 0, it's good. Yeah, exactly. Gotta restart. All right. See you in a minute. All right, now what's happening here? A squared, C squared, minus 2ABCD, everyone's favorite number, plus B squared, D squared, plus a squared d squared plus 2abc. I feel like I've done this multiplication a bajillion times by now. And then we get a squared c squared plus c squared, or b squared c squared plus a squared d squared, plus b squared d squared. Okay. Okay, and yeah, okay, these two terms cancel, and then we're good. I'm not going to bother writing that out, because I'm going to have to put it in LaTeX anyway. And I'll do it then. Okay, so we justified that step. Caveman. Caveman math is best math. We should have a much shorter proof on our hands for this one, which is that the magnitude of z is equal to the magnitude of z conjugate. Can I just now we can, because we have this now, it is helpful to use the polar form, because we can actually justify what I wanted to do in the last problem, which is this. Good. Okay. I hope this will make sense to me when I go back to read it later to put it into LaTeX. So this homework is a little bit tedious because I now have to draw this too. This entire homework assignment has been pretty tedious, to be honest, so far. Just having to do a lot of like really menial calculations. Okay, so let's actually calculate wz conjugate plus w conjugate z minus 2. And we'll put that result, I guess, in light green. And then now we want two times wz for the right side. Well, no, none of that. Let's just do the mod at the end. Minus 1 plus I, 2 plus I. Minus 2 minus I plus 2I minus 1. Two minus 3 plus I minus 6 plus 2I. Oh, that's such a good emote. I've seen that around before. Is that a new one? I didn't realize it was a global emote. Do I have it? Snake in box. I do have it. Oh, do you not know Metal Gear Solid? It's a reference to that game. Oh, it's a video game where the character is named Snake, and in order to stealth past enemies, he can go inside of a cardboard box and sneak around. It would be confusing if you didn't know that because like, snakes don't have legs, right? Yeah. That emote would be confusing. Yeah, seeing people like use that emote, and I thought it was like you had to like unlock it, or it was some streamer's emote or something. Okay, -6 plus 2i. You will be red. 1, 2, 3, 4, 5, 6. Okay, is this my picture? Draw a picture which represents each of them. The important feature of this graph is that this length is longer than this length, I guess. So we've done it. Yeah, it's a good bit longer in this case. I think because I chose complex numbers with opposite signs for the real parts. Or maybe, well, it's multiplication. I don't know. Hey, Christian, my favorite field of maths, like dynamical systems slash differential equations, I guess. Hope you're doing well. I mean, there's the trivial case if both W and Z are 0. I don't know if there's a non-trivial case. I don't feel like trying to think of a non-trivial one right now, to be honest. W equals Z, W equals conjugate Z. Oh, if they equal each other? Ooh. That's probably I probably should have thought of that. Yeah, if you just have or yeah, a simple one is if they're just the same real number. That would be equality, right? All right, so now we need to draw part B, and then we'll draw part A. Because that's, the natural order to do things in. Oh, not red. Why does homework involve drawing? Ask my professor. No, I mean, this does have a real, like, geometric interpretation, all of these complex, like, number relationships. So that's probably why, but... All right, so we'll draw the original complex number in green. Oh, I never really thought about it, but to go with the vector metaphor, the real and imaginary functions are like a projection, like a vector projection. Again, I chose a bad number. No, you know, it's okay. So the magnitude of this thing, is it 2 root 2? Square root 2 squared plus 2 squared. Yeah, 2 root 2. So that's 2 root 2 is 2.8. I guess that's my drawing for that one. Funny proof. Cosine of x is less than or equal to 1. How would you prove that? Probably with the complex definition. Real part of z is projection onto the x-axis, so real part of z is just c cosine theta. Oh, yeah. That's funny. Hey, IVK. Oh, use that. Yeah, okay, yeah. You know, that's probably a valid way of doing it too. I think for that one, I just did it caveman. But that's a clever way of doing it. So yeah, for that one, I've already like latexed up the solution that I found, so I'm just going to stick with that. But that is a nice way of thinking about it. IVK, we're just talking about how to prove this for complex numbers. I already found a proof, but JC YW suggested a clever way with using cosine. Was saying like the real part of z is equal to the magnitude of z cosine theta, and cosine is bounded by 1. No, I just am not good at proving things, so I always do it the caveman way. Unless I can think of a more clever way. Which, to be fair, I did think of a more clever way for that part 3. So not all hope is lost. That's so real. Oh, right. Cave hearts. Yeah. Maybe IVK. That feels a little bit indirect. The proof for this one would follow kind of directly from the cosine thing that JC was suggesting. Say that the real part of z is equal to magnitude z cosine theta. And that's just because cosine is bounded by 1. You just already know that it's less than or equal to magnitude of z. Also, like correlation coefficients are bounded by -1 and 1? Really? I didn't know they had anything to do with that. Oh, you know what? That does. I do remember learning that linear regression can be done with like linear algebra and projections. So maybe that I guess that makes sense for why a cosine would be involved there. I didn't really understand the explanation that I saw, but it was interesting to see that. I think let's use our same values for z and w here. I don't think we really have to be exactly accurate like how I'm being here, but I just kind of want to be. Like I think a sketch of these would suffice for the class. But if I sketch it, I'm gonna get sloppy. What's C? Like part C? Part C was this one right here. I've already proved it. But that's what it was. Can you use the mobs with that? IPK? Like for the power of a complex number? I don't see how. Correlation coefficient is just normalized to 1. You can normalize to 2 for all you want. Oh, really? Then I don't know. B equals X prime. Yeah, that looks familiar. So, I will regress you. So, I guess, you'll be fitted with a line. Prime is in transform? Yeah, like a transpose. Trying the best way to do this without making the picture too messy. Because Z plus W, I guess we would go there. Which means Z plus W conjugate would go down here. But then we also have Z conjugate plus W conjugate. At the same place. I guess that's my picture. It's a little bit messy, but like it works. I think. You don't remember the name? Oh, okay. Integration? This is my homework. I have to do this whether I like it or not. We are going to move on to a different type of problem though. Because we finished up this proof one. We've got a branch cut question. You. I mean, it's still complex numbers, yeah, but it's not the the exact type of complex number question. Queso Prime 9, hello, welcome in. Hibbed, can you explain if f of x has 2 repeating roots, f prime x has 1 repeating root? Thank you for the follow, Queso Prime. Yes. Oh, yes? So 2 repeating roots, do you mean like, if f of x is like x minus 1 squared times x minus 2 squared, like this would be 2 repeating roots? Or do you mean a different type of function? X squared minus 1 squared. Okay, so yeah, that one also works. I think the best way to see it is to just take the derivative and do not bother multiplying this out. Because we can use the power rule and the chain rule here. So first off, I'm going to use the power rule and that's squared. So the 2 comes down. Then we get x squared minus 1. Now times the chain rule, we have to multiply by the derivative of the inside. And that's just 2x. And so we can rearrange this to be 4x, x squared minus 1. We don't have any repeating roots here. So I guess I'm not quite sure what you're maybe trying to get at with this example. So it is true in this first one we have 2 repeated roots. But because of the way that the power rule works, like we end up bringing this exponent down, and so that's how like derivatives can make a root go from repeated to not repeated. And so even if you guess something that's a little more complicated, like the example that you gave, stuff like that can still happen for the reason that we just saw. So I hope that answers your question, but let me know if I didn't understand. Hey Rex, hope you're doing well. Oh, it'll only work in the Twitch chat. Okay. I do have other commands set up in the YouTube chat, but not that many. My friend said I know that Rex's friend said that I know so much that I should have a PhD. I don't think so. I appreciate the kind words, but I definitely don't know that much. The playlist, I set it at Spotify Radio, set to a certain song. The song that I set the radio to is Willow by Gamma Flow, which is a banger. Commands to remove JE people. If I could have a command like that, I would. All right, so how we deal with this type of question is going to be defining some local polar coordinates. No, that's not a problem you solve with banning. there, if someone legitimately has a question, comes in and asks me, and I can't do it, it's not their fault. Oh my god, I didn't mean to do that. It uses LMVT as a concept. Someone's mean value theorem, like Lagrange's or Laplace or something. I don't know. It is kind of the principle where f x equals 0 has m repeating roots, and f prime x has m minus 1 roots. LMVT is just the mean value theorem, right? By a different name. Yeah, Lagrange's mean value theorem. Really? Right. Okay, that's the mean value theorem. Why would the mean value theorem help with those? Um, like hmm. I can tell you that like if a function f of x has a repeated root, it can be written in the form f of x equals x minus r to the m times some other polynomial, where r is the repeated root. You could, like, if you want to, like, show this in general, like, you could do a general kind of thing like this. And you can take the derivative of that. Let me write out f of x first. So if you take the derivative of this thing here, we'll do a product rule on this. So I'll take the derivative of this piece first. We get m x minus r to the m minus 1 p of x plus x minus r p prime x. And so from, oops, to the m. And so the point here is we can only factor m minus 1 many of the repeated roots out now. And then inside the parentheses, we get m p of x plus x minus r p prime x. Zach, thank you so much for the raid. Welcome in, people. Ivan, hello. Hope you're doing well. For anything on my end, check out Zach / eats a toy pie. I was lurking on you. I saw you were talking about fractions. I hope it went well. What we're doing today is in the background, I've been working on homework for my complex analysis class. We're about to do this one on branch cuts. Oh, we got a question from Hibbit in the YouTube chat. Um, about functions with repeated roots and how their derivatives will have that repeated root, but like with one less multiplicity. Fractions are more my speed. That's fair. Partially inspired by somewhat personal experience. Ooh, okay. And so there's apparently some mean value theorem approach to thinking about this question. I'm not quite sure what it would be. To me, like this here is good enough because this is just some new polynomial. We don't even care what. As long as it is a polynomial, which it is. I've missed a few YouTube chats. I don't really have an email that's like that. Hibbit. Like I have a Discord server, but email's a little bit hard for me. Hey, Walter. Okay, so yeah, I'm not sure where else to take this, Hibbit. I'm not really good with JEE questions. They often want something that's kind of specific, so I might not be able to help with that. But this is the idea that I would use for something like that. God, IVK, I'm not making you mod. Syntax, all my polynomial roots repeated. I haven't rated you forever. You rated me for the coding competition. But yeah, I just haven't been streaming too much. That's true, yeah. You've been holding up your end, Zach. You've been streaming a lot recently. Oh God, IVK, please just like, calm down. Like yeah, if you post it, I'll look at it. I'm not gonna make any promises that I can actually like help with it. In the meantime, I'm gonna back to think about this, but if I see you post something, I'll come back to it. Okay. That'll be the day, IVK. So what do we get? R1e to the I theta 1 to the 1/2. R2 e to the I theta 2 to the -1/2. And then we can bring the negative. Actually, we can just R1 to the 1. I mean, okay, yeah. Let's R1 R2 to the 1/2. That's not very interesting. Do we want to combine them into one exponent? I don't know why I said it like that. Exponent? Sure, why not? Theta 1 minus theta 2 over 2. That's kind of weird. We get a negative sign. for theta 2. Hmm. That was mine. This doesn't sound like Minecraft music. It's not Minecraft music that I've heard. What the hell? Do they not have the relaxing piano anymore? Oh, the start. Okay, okay. No, you definitely get copyrighted on Twitch. You just don't get caught for it if it doesn't get saved into the VOD. So if you have your VODs turned off, or if you do what I do and set it up so the music doesn't get sent to the VOD, you're fine. The song's called Aria Math. Oh, okay. I actually do I still have Minecraft playlist saved? I do. The Minecraft soundtrack. I don't see it in this list though that I have. Oh, I because I have the volume alpha playlist saved because that's when I was playing Minecraft. I it's in volume beta. Okay, well I'm too lazy to actually look for it, but welcome back, Stefan. Play Minecraft cover of I don't know what that is, but you won't hear it on YouTube anyway. Okay, so the way that we were kind of taught to think about branch cuts here is to do this A/B test thing that the question mentions. You have a math exam in like a week. Can I look at it? Like, if it's an actual test, I can't help you with that. If it's like a practice thing or something like that, I can look at it, sure. But if you're not supposed to have help, then I, wouldn't help you cheat with something. Um, so okay, okay. Yeah, I just want to make sure I put that disclaimer out there. uh, the A/B test, JC, it's basically taking the left-handed and right-handed limit, like as you go, as theta goes to 0 from the right, and then as theta goes to 2 pi from the left, and comparing those. It's doing the one-sided limits without doing the actual limits. I probably have to get my notebook out to remember exactly how this works, but that's fun. The best way would just be to post it in my Discord. Uh, so z minus 1 wants, when the angle is measured like this, z minus 1 square rooted wants to have a branch cut like this. I see you posted it. It's in Serbian. That's fine. How long? Oh god. Okay, so it's 7 pages. Oh, but these are solutions also. So I don't know if we'll do all of these. So is there like a specific one that you wanted to like talk about here, or this looks like quite a few questions. So I don't think I can go through all of these. Four, five, and six. Okay. Yeah, I'll need you to translate these for me. So that I can figure out the question just based off what the math looks like. These look like the equation for planes, but I don't know what to do with them. You're gonna do it alone. Oh, okay. Yeah. So if you want to think about them for yourself first, then uh, I'll let you do that before I dig into them. It's a bird. It's a plane. I bet if they're giving us two planes, they want us to find the intersection between them. But if I had to guess, that's what's happening. But I'll leave it for whenever we want to talk about it, I guess. We'll intersect your planes. There you go. First, you linear regress me, and now you're going to intersect my planes. Okay, so we should what branch cut does the other piece want to have if it was alone? Determine the common normal of the lines. Oh, okay. Stochastic calculus by Shreve? I mean, I don't know anything about stochastic calculus. Like, what would you want to hear about it? Like, an opinion on the book? There's a math channel that does a bunch of opinions on math textbooks. But like, I don't know what you would gain from me looking at the cover of a book. What is that math chit? Is it like Adventures in Math or something? Math Adventures that reviews math books? I don't remember. I can just the math sorcerer. Okay. No, this isn't the one that I was thinking of. What the hell is this dude? That's not the channel I was thinking of. Or he got hacked or something. Uh Oh my god, he's all these videos are from the last week. Dude, he's been posting so many videos. Uh huh. I do think that's a channel I was thinking of too. Go to his shorts and scroll down. Okay. Yeah, it seems like something's wrong with him, which is maybe a shame. Well, not maybe a shame. Maybe something's wrong with him, which would be a shame. How it's not that one, Stefan. Oh my god. I'm just gonna move on. I don't know what's happening there, and I've never said it's gonna be something that I shouldn't show on stream. So I can't say I've had pickle Pepsi. I don't imagine I would enjoy it. Ooh, is this negative exponent going to reverse the direction of the branch cut? That would be kind of interesting if it does. So I just want to consider separately z minus 1 to the minus a half. Okay, so if this was a positive exponent, the branch cut would be going this way. I become like, I mean, I don't know if he actually is crazy or not. Maybe he's just feels like posting motivational stuff. So I'm not judging him. That's just not what I expected to see on his channel. I guess that's the question, JC. I don't know. I feel like that this negative sign does kind of risk flipping it, and if it doesn't, I want to feel like I understand why it doesn't. So basically, the A/B test. I have a point A here that's going to approach like theta equals 0, and a point B here that'll approach 2 pi for the angle. And if they come out to be the same thing, then there's no branch cut there. I do want to find my journal. I found it quickly. Just remember exactly that we were doing it in class. Which, by the way, there's not that many people in my classes who take notes by hand still. It's kind of weird to me because handwriting is so, it helps me out so much. But no one does it anymore. That's right. We're actually going to plug in theta equals 0, theta equals 2 pi. Okay, so around A, it's going to look like RE to the minus I times 0 over 2, which is just R. Around B, it's going to be RE to the minus I 2 pi over 2. So we're going to get RE to the minus I pi. Is that still negative 1? That's kind of boring. I wanted it to do something more interesting, like flipping the direction of the branch cut. Because choose your branch cuts freely when you're doing integration. Yeah, that's true. FSBWV, hello, welcome in. You're a math tutor in college, want to see what it looks like in the YouTube streaming era. Oh, nice. Yeah, so my background is I have been a math tutor. I have a bachelor's in applied math, minor computer science. I just started a few weeks ago on a master's in applied math. And I've been doing this stream for about 2.5 years now. I dual stream to Twitch and YouTube. I consider Twitch my like primary platform. I have heard of the Pornhub math teacher dude. But yeah, so the theme of the stream is I kind of hang around and wait for someone to ask a question from chat, and I'll do my best to answer it. When there isn't a question, I'll do basically homework for my classes. And so this is what's happening right now. If you're interested in this type of stream in general, on YouTube there aren't too many people. Here are two friends of the channel though. On Twitch there's a bunch of people who live stream math, but on YouTube those are the only two people who I know of. My degrees are in math and stats with a minor in education. Nice. That is funny to misspell education specifically. No worries. This isn't we don't use spell check on this channel. He's expanded his empire to other sites. Oh, that's funny. I should triple stream on Pornhub as well. You know, maybe there's an audience there. Yeah, I do know if we define the angle differently, that's what would really control the branch point. I've never encountered the negative sign there, so I wanted to assure myself that it wouldn't change anything, I guess. Okay. It's boring though. I wanted something cooler. I think that'd be hard to focus on the math with all the ka-ching in the background. I definitely am not as productive when I stream, but there's a really cool exchange that happens whenever I do stream where chat kind of gives ideas and we discuss problems, and I definitely do better math when I'm on stream. I just don't do as much of it. Stooky, I spent the last 2 hours cleaning a mouse inside of my room. Attempt 2, I guess. Oh no. Only an hour and change. Okay, that's better. My mouse needs to be cleaned, and I need to clean my keyboard. There's a lot of things that I need to clean. Wasn't there a gaming scene on Pornhub? I think people were uploading like Halo videos to Pornhub back in the day. I feel like I heard of that. Chat's a free association machine? Yeah. Oh, about the adult site thing. Sorry. I get it now. Man, if I was that successful with the ka-ching always going off, that would be great. I would probably do it. Oh god, IBK, that one got held for review. I don't quite know what it means, so I might just leave that one be. I'm pretty sure that there was a dude who was actually posting math videos on Pornhub. I don't know for sure, but there's definitely been a lot of like non-porn, non-sexual stuff posted there as a joke. Or maybe it's serious. I don't know. Getting fucked by Calc 3. Watch my toes curl while I diverge from my field. Oh, that's terrible. Student gets fucked by homework. Oh my god. I'm pursuing a master's in applied math. Hibbit. Yeah, it's zap, and it'll be really easy to pivot my career if I do have an existing channel on Pornhub. Or I guess my existing lack of career, more like. Okay, so I think we can agree, or I can agree with myself, that the branch cut due to the negative sign doesn't really it's still the same. It's just going out to positive infinity. This feels lame. It's just like this just feels so normal. So if we do the A/B test here and here, it's going to be the exact same thing as we just did down here. We'll get that this does need to be a branch cut. So the more interesting thing is going to be to do the A/B tests here and here, and we should assure ourselves that these discontinuities do cancel. Oh wait, maybe this will be interesting. So A, B, Grand Sumo. I never heard of Grand Sumo. Thank you for the kind words, Hibbit? Question mark. If you tutor other people, you can just send them the Pornhub links to my tutorials. Yeah, true. Oh, this is not accurate what I wrote here. It would be R1 over R2, right? It's not really important, but this is a good song with the piano. It's 24 years ago. Oh, dang. Okay, so if I'm at point A, theta 1 and theta 2 are gonna both measure 0. So we're just gonna get R1 over R2. If I'm at B2, or if I'm at B, theta 1 and theta 2 are both gonna measure 2 pi still. We're gonna get 0 because the 2 pi's cancel. That's kind of funny. So there is no, and so the important bit here is that we're still getting positive 1. Man, this is so boring. It makes sense though, because doing 1 over a complex number may as well be the conjugate of another complex number, and conjugating shouldn't really change the branch cut. I thought this would be some kind of weird function and we have to be careful and do something a little like careful. But it's just kind of the answer that you would expect it to be, which is just the branch cut there. Can we verify this? Like, does Wolfram Alpha know how to find branch cuts? If I just gave it the function. But at least with like if you have like a 1/6 power, you or like no, an example we looked at in class that was more exciting to me was it was something like z plus 1 to the 1/2, z plus z minus 1 to the 1/3. This one was a little more interesting because the branch cuts did not end up canceling, or yeah, and so it ended up going out to infinity rather than connecting the 2 points. Well, it connects to the 2 points and it goes out to infinity. Like that's what I mean by more interesting, I guess. But this one was just kind of plain Jane. Okay, I think I've answered every part of number 3 then. What's the reputation of JE people here? uh, I I I personally don't like working on JE questions because they're insanely difficult. I don't know the techniques that they ask you to use, and I don't particularly care to learn them. There's a shitload of people who are always asking me if I can do JE questions, which is why I pinned that. I wish I did know them and that I could work on them, but it's just way too much trouble for math that I'm ultimately not interested in. And it doesn't help that most of the people who ask me to work on JE questions have an attitude. And half of them are just giving me insanely difficult problems because they just want to see someone fail at a problem they know how to do, is the feeling that I've gotten from many of them. So that's the reason why I just don't want to do them in the first place. Like, I I feel bad and I apologize to anyone who's studying for it who's just like legitimately wants some help, but I've tried to do those problems endlessly and I've failed, and I'm kind of done with it. If you all have J people on YouTube, just say how it's the hardest game in the world. It's like it's nowhere near. Yeah, they definitely. There's a lot of people who have an ego about how hard the test is, and they take like pride in that. Yeah, exactly. It's a lot of like memorization, which I really hate. Hey, can you quickly prove that all natural numbers more than 2 can be expressed as the sum of 2 primes? Yeah, K-Parse, let me get right on that. Does that one have a name? I've heard that, but before. That's a Goldbach. Right. Hey, Broral. Hope you're doing well. People come in spam here. They don't understand. Yeah. I'll say I don't know how to do them, and they'll just keep on asking me to do them. Be really insistent. Okay. Let's z equals x plus iy. Express the real imaginary parts of sinh z as the product of trig function and hyperbolic. Really? Okay. Well, I guess let's look at the definition of sinh first. I should be able to figure this out because it's odd, right? So e to the z minus e to the minus z over 2, just 2. Is that it? I'm going to make sure. Hey, I got it. $27 is a fake number anyway. Where is there 27? I do like that theory. 27 is a fake. Oh, because of the Goldbach conjecture. Wait, does 27 break that? Are there no primes that sum to 27? Surely we would have found that. 23 and not 4. Parse. Oh, okay. Oh, even. Okay, yeah. Okay. Have they heard about the ISI exam? I'd never heard of the ISI exam personally. Well, okay, so the real and imaginary parts of sinh is a real function. What the hell are you saying? Well, I guess it's of a complex number. Okay, okay, never mind. Hey, Alan G.R. Bovic. I'm doing good. How about you? Well, welcome in. Okay. Debating the best way to split this thing up. Like, it's the e to the minus x that's annoying me here. I just want to factor out an e to the x, but it doesn't really work. I guess let's do this. Just hope it works out somewhere over the rainbow. Gonna learn a song on your guitar and to get to integration. Hey, that's a productive thing to do. You should do exactly that. Is there any proof for natural log? You only know how it works. Where do we get it from? Well, we can't really prove natural log. It's a definition. Where it comes from is in math we often run into equations that are like 2 to the x equals 8, and there isn't always a great way of solving these. I chose an easy, like an example that we actually could solve, because we if we know that 8 is 2 cubed, we could write it like this and see that x must be 3. But if I instead made it 2 to the x equals 9, this gets a lot harder. We can't use that same trick. And so if all we had this equation, we would get a little bit stuck. So what we do instead is we invent this thing called well, I guess logarithms. So we could translate this one into a log equation by saying log base 2, because that's the base of the exponent, of 9 equals the exponent. So these two equations mean the exact same thing, but this one we can actually work with because we figured out how to evaluate logs. They have a bunch of really nice properties. And so I won't bother doing it because you just plug it into a calculator. But if you wanted to, you could figure out that number and it'll be a decimal. Whereas you couldn't easily do that with this. And so you did say natural, like specifically the natural log, which is log base e, or ln for short. I don't know why it's ln and not nl. That's kind of weird, but it's the same thing as a normal log. It's just this number e that's here. I don't know if you know what e is already, or if that's what your question is about. But it's called Euler's number. It's an irrational number. That's it's just like pi, but it's 2.71 something instead of 3.14. And there's no reason we really have to use this number ever, but it just makes things a lot cleaner often in math. So we tend to just use it for everything. There are some applications where it's better to use base 10 or base 2. but absent some application, we usually just default to base E because it makes certain things very clean in math. So yeah. Oh right, I do remember that Hibbit. Derived from Latin term. Oh really? Liberatus naturalis. That makes sense. Thank you, FSB. That's cool to know. It's fun just baiting people into trying to solve the Millennium Prize problem they don't know are hard, seeing if they get it out of naive confidence. I've had to learn about Lazar because enough people were asking me to solve them as a joke, but I didn't realize it was a joke. A to the x whose derivative proportionality constant is 1. Oh, that one I actually don't know. You could have got me with that. Multiply top and bottom by e to the z. I was wondering about doing that, JC. I feel like I could get away with not doing that. IBK, I would love that. I would send every last person your way who asked me about JE. You would probably have a pretty successful YouTube channel if you did stream about the JE. Oh, you looked it up? That's fair. I was really impressed with you. I completely believe that you just knew that offhand, FSB. Flying socks butt. Hello, welcome in. Hope you're doing well.